Welcome back. Let's start reading a bit today. I have a lot of old aircrafts. I have another fly. I have many flies, my whole apartment. So I need to move it away. Every time I see a fly, I need to try get it. But I'm too slow. No, that's too fast. I'm too old and slow. I have many old fighter jets I like to read about, so let's start. And I make some video in my language, Danish. It was supposed to be in English too. This is a very long one. I don't think that's not enough power for this long one, but let's get started.
Gloster Meteor. The Gloster Meteor was the first British jet fighter and the Allies' only jet aircraft to engage in combat operations during the Second World War. The Meteor's development was heavily reliant on its groundbreaking turbojet engines, pioneered by Frank Whittle and his company. Powerjet's limited development of the aircraft began in 1940, although work on the engines had been underway since 1936. The Meteor first flew in 1943 and commenced operations on the 27th of July 1944 with number 616 Squadron IF. The Meteor was not a sophisticated aircraft in its aerodynamics, but proved to be a successful combat fighter. Gloster's 1946 Civil Meteor F.4 demonstrator GAIDC was the first civilian-registered jet aircraft in the world. Several major variants of the Meteor incorporated technological advances during the 1940s and 1950s. Thousands of Meteors were built to fly with the RAF and other air forces and remained in use for several decades. Slower and less heavily armed than its German counterpart, the jet-powered Messerschmitt Me 262, the Meteor saw limited action in the Second World War. Meteors of the Royal Australian Air Force, RAF, fought in the Korean War. Several other operators such as Argentina, Egypt and Israel flew Meteors in later regional conflicts. Specialized variants of the Meteor were developed for use in photographic aerial reconnaissance and as night fighters. The Meteor was also used in research and development and to break several aviation records. On the 20th of September, 1945, a heavily modified Meteor I, powered by two Rolls-Royce RB.50 Trent turbine engines driving propellers, became the first turboprop aircraft to fly. On the 7th of November, 1945, a Meteor F.3 set the first official airspeed record by a jet aircraft at 606 miles per hour, 975 kilometers per hour. In 1946, a Meteor F.4 reached a record speed of 616 miles per hour, 991 kilometers per hour. Meteors also broke records in flight time, endurance and rate of climb. On the 10th of February, 1954, a specially adapted Meteor F.8, the Meteor Prone Pilot, which placed the pilot into a prone position to counteract inertial forces, took its first flight. In the 1950s, the Meteor became increasingly obsolete as more nations developed jet fighters, many of which used a swept wing instead of the Meteor's conventional straight wing. The RAF service replaced its Meteors with newer types such as the Hawker Hunter and Gloster Javelin. As of 2023, 2 Meteors, GJSMA and GJWMA, remained in active service with the Martin Baker Company as ejection seat testbeds. One further aircraft in the USA remained airworthy, as did another in Australia. Development, edit. Origins, edit. See also, Frank Whittle. The development of the turbojet-powered Gloster Meteor was a collaboration between the Gloster Aircraft Company and Frank Whittle's firm, Power Jets Limited. Whittle formed Power Jets Limited in March 1936 to develop his ideas of jet propulsion, Whittle himself serving as the company's chief engineer. For several years, attracting financial backers and aviation firms prepared to take on Whittle's radical ideas was difficult. In 1931, Armstrong Siddeley had evaluated and rejected Whittle's proposal, finding it to be technically sound but at the limits of engineering capability. Securing funding was a persistently worrying issue throughout the early development of the engine. The first Whittle prototype jet engine, the Power Jets WU, began running trials in early 1937. Shortly afterwards, both Sir Henry Tizard, chairman of the Aeronautical Research Committee, and the Air Ministry gave the project their support. On the 28th of April, 1939, Whittle made a visit to the premises of the Gloster Aircraft Company, where he met several key figures, such as George Carter, Gloster's chief designer. Carter took a keen interest in Whittle's project, particularly when he saw the operational Power Jet's W.1 engine, and quickly used it as the basis for several rough proposals of various aircraft designs. Independently, Whittle had also been producing proposals for a high-altitude jet-powered bomber, although following the start of the Second World War and the battle for France, a greater national emphasis arose on fighter aircraft. Power Jets and Gloster quickly formed a mutual understanding around mid-1939. The Gloster E.28/39. The yellow undersides were standard for RAF training and prototype aircraft of the period. In spite of ongoing infighting between Power Jets and several of its stakeholders, the Air Ministry contracted Gloster in late 1939 to manufacture a prototype aircraft powered by one of Whittle's new turbojet engines. The single-engined proof-of-concept Gloster E.28/39, the first British jet-powered aircraft, conducted its maiden flight on the 15th of May 1941, flown by Gloster's chief test pilot, Flight Lieutenant Philip Jerry Sayer. The success of the E.28/39 proved the viability of jet propulsion, and Gloster pressed ahead with designs for a production fighter aircraft. Due to the limited thrust available from early jet engines, it was decided that subsequent production aircraft would be powered by a pair of turbojet engines. In 1940, for a military load of 1,500 pounds, 680 kilograms, the Royal Aircraft Establishment, RAE, had advised that work on an aircraft of 8,500 pounds, 3,900 kilograms, all up weight, with a total static thrust of 3,200 lbf, 14 kN, should be started, with an 11,000 pound, 5,000 kilograms, design for the expected, more powerful, W.2 and axial engine designs. George Carter's calculations based on the RAE work and his own investigations were that a 8,700 to 9,000 pound, 3,900 to 4,100 kilogram, aircraft with 2 or 4 20mm cannons and 6 0.303 machine guns would have a top speed of 431 miles per hour, 348375 kn, 644694 km/h, at sea level and 45470 miles per hour, 39410 kn, 72760 km/h, at 30,000 feet, 9100 m. In January 1941, Gloster were told by Lord Beaverbrook that the twin-jet fighter was of unique importance, and that the company was to stop work on a night fighter development of their F.9/37 to specification F.18/40. Prototypes, edit. In August 1940, Carter presented Gloster's initial proposals for a twin-engined jet fighter with a tricycle undercarriage. On the 7th of February 1941, Gloster received an order for 12 prototypes, later reduced to 8, under specification F.9/40. A letter of intent for the production of 300 of the new fighter, initially to be named Thunderbolt, was issued on the 21st of June 1941. To avoid confusion with the USAF Republic P-47 Thunderbolt, which had been issued with the same name to the RAF in 1944, the aircraft's name was subsequently changed to Meteor. During the aircraft's secretive development, employees and officials made use of the codename Rampage to refer to the Meteor, as similarly the de Havilland Vampire would initially be referred to as the Spider Crab. Test locations and other key project information were also kept secret. Although taxiing trials were carried out in 1942, it was not until the following year that any flights took place due to production and approval hold-ups with the Power Jet's W.2 engine powering the Meteor. On the 26th of November 1942, production of the Meteor was ordered to stop due to the delays at subcontractor Rover, which was struggling to manufacture the W.2 engines on schedule. Considerable interest was shown in Gloster's E.1/44 proposal for a single-engine fighter, unofficially named Ace. Gloster continued development work on the Meteor, and the production stop order was overturned in favor of the construction of 6, later increased to 8, F.9/40 prototypes alongside 3 E.1/44 prototypes. Due to the breakdown in the relationship between Rover and Power Jets and the availability of Rolls-Royce's supercharger division, responsibilities for development and production of the W.2B engine were transferred to Rolls-Royce that year. On the 5th of March 1943, the fifth prototype, serial DG206, powered by two substituted de Havilland Halford H.1 engines owing to problems with the intended W.2 engines, became the first Meteor to become airborne at RAF Cranwell, piloted by Michael Daunt. On the initial flight, an uncontrollable yawing motion was discovered, which led to a redesigned larger rudder. However, no difficulties had been attributed to the groundbreaking turbojet propulsion. Only 2 prototypes flew with de Havilland engines because of their low flight endurance. Before the first prototype aircraft had even undertaken its first flight, an extended order for 100 production standard aircraft had been placed by the RAF. The first Whittle-engined aircraft, DG205/G, flew on the 12th of June 1943, later crashing during takeoff on the 27th of April 1944, and was followed by DG202/G on the 24th of July. DG202/G was later used for deck handling tests aboard aircraft carrier HMS Pretoria Castle. DG203/G made its first flight on the 9th of November 1943, later becoming a ground instructional airframe. DG204/G, powered by Metrovic F.2 engines, first flew on the 13th of November 1943, DG-204-G was lost in an accident on the 4th of January, 1944, the cause believed to have been an engine compressor failure due to overspeed. DG-208-G made its debut on the 20th of January, 1944, by which time the majority of design problems had been overcome and a production design had been approved. DG-209-G was used as an engine test by Rolls-Royce, first flying on the 18th of April, 1944. DG-207-G was intended to be the basis for the Meteor F.2 with de Havilland engines, but it did not fly until the 24th of July, 1945. At which time the Meteor 3 was in full production and de Havilland's attention was being redirected to the upcoming de Havilland Vampire. Consequently the F.2 was cancelled. Into production, edit. On the 12th of January, 1944, the first Meteor F.1, serial EE210-G, took to the air from Moreton Valence in Gloucestershire. It was essentially identical to the F9-40 prototypes except for the addition of 4 nose-mounted 20mm .79 Hispano MKV cannon and some changes to the canopy to improve all-round visibility. Due to the F.1's similarity to the prototypes, they were frequently operated in the test program to progress British understanding of jet propulsion, and it took until July 1944 for the aircraft to enter squadron service. EE210-G was later sent to the US for evaluation in exchange for a pre-production Bell YP-59 Airacone, the Meteor being flown first by John Grierson at Muroc Army Airfield on the 15th of April, 1944. Originally 300 F.1s were ordered, but the total produced was reduced to 20 aircraft as the follow-on orders had been converted to the more advanced models. Some of the last major refinements to the Meteor's early design were trialed using this first production batch, and what was to become the long-term design of the engine nacelles was introduced upon the E211. The original nacelles had been discovered by the Ray to suffer from compressibility buffeting at higher speeds, causing increased drag. The redesigned longer nacelles eliminated this and provided an increase in the Meteor's maximum speed. The lengthened nacelles were introduced on the final 15 Meteor 3s. EE215 was the first Meteor to be fitted with guns. EE215 was also used in engine reheat trials, the addition of reheat increasing top speed from 420 miles per hour to 460 miles per hour. It was later converted into the first two-seat Meteor. Due to the radical differences between jet-powered aircraft and those that it replaced, a special tactical flight or T-flight unit was established to prepare the Meteor for squadron service, led by Group Captain Hugh Joseph Wilson. The tactical flight was formed at Farnborough in May 1944, the first Meteors arriving the following month, upon which both tactical applications and limitations were extensively explored. On the 17th of July 1944, the Meteor F.1 was cleared for service use. Shortly afterwards, elements of the tactical flight and their aircraft were transferred to operational RAF squadrons. The first deliveries to number 616 Squadron RAF, the first operational squadron to receive the Meteor, began in July 1944. When the F.2 was cancelled, the Meteor F.3 became the immediate successor to the F.1 and alleviated some of the shortcomings of the F.1. In August 1944, the first F.3 prototype flew. Early F.3 production aircraft were still fitted with the Welland engine as the Derwent engine's production was just starting at this point. A total of 210 F.3 aircraft were produced before they were in turn superseded by production of the Meteor F.4 in 1945. Several Meteor F.3s were converted into navalized aircraft. The adaptations included a strengthened undercarriage and a rester hook. Operational trials of the type took place aboard HMS Implacable. The trials included carrier landings and takeoffs. Performance of these naval prototype Meteors proved to be favorable, including takeoff performance, leading to further trials with a modified Meteor F.4 fitted with folding wings. A clipped wing was also adopted. The Meteor later entered service with the Royal Navy, but only as a land-based trainer, the Meteor T.7, to prepare pilots of the Fleet Air Arm for flying other jet aircraft such as the de Havilland Sea Vampire. While various marks of Meteor had been introduced by 1948, they had remained very similar to the prototypes of the Meteor. Consequently, the performance of the Meteor F.4 was beginning to be eclipsed by new jet designs. Gloster therefore embarked on a redesign program to produce a new version of the Meteor with better performance. Designated Meteor F.8, this upgraded variant was a potent fighter aircraft, forming the bulk of RAF Fighter Command between 1950 and 1955. The Meteor continued to be operated in a military capacity by several nations into the 1960s. Night Fighter, edit. To replace the increasingly obsolete de Havilland Mosquito as a night fighter, the Meteor was adapted to serve in the role as an interim aircraft. Gloster had initially proposed a night fighter design to meet the Air Ministry specification for the Mosquito replacement, based on the two-seater trainer variant of the Meteor, with the pilot in the front seat and the navigator in the rear. Once accepted, however, work on the project was swiftly transferred to Armstrong Whitworth to perform both the detailed design process and production of the type. The first prototype flew on the 31st of May, 1950. Although based on the T.7 twin-seater, it used the fuselage and tail of the F.8, and the longer wings of the F.3. An extended nose contained the AIMK-10. The 1940s Westinghouse SCR-720 air intercept radar. As a consequence, the 20mm cannons were moved into the wings, outboard of the engines. A ventral fuel tank and wing-mounted drop tanks completed the Armstrong Whitworth Meteor NF.11. Operational Meteor NF.14 of No. 264 Squadron RAF in 1955. As radar technology developed, a new Meteor night fighter was developed to use the improved US-built APS-21 system. The NF.12 first flew on the 21st of April, 1953. It was similar to the NF.11 but had a nose section 17 inches, 43 centimeters, longer. The fin was enlarged to compensate for the greater keel area of the enlarged nose and to counter the airframe reaction to the sideways oscillating motion of the radar scanner, which caused difficulty aiming the guns. An anti-tramp motor operating on the rudder was fitted midway up the front leading edge of the fin. The NF.12 also had the new Rolls-Royce Derwent 9 engines, and the wings were reinforced to handle the new engine. Deliveries of the NF.12 started in 1953, with the type entering squadron service in early 1954, equipping 7 squadrons, numbers 85, 25, 152, 46, 72, 153 and 64. The aircraft was replaced over 1958-1959. The final Meteor night fighter was the NF.14. First flown on the 23rd of October, 1953, the NF.14 was based on the NF.12 but had an even longer nose, extended by a further 17 inches, 430 millimeters, to accommodate new equipment, increasing the total length to 51 feet 4 in, 15.65 m. and a larger bubble canopy to replace the frame T.7 version. Just 100 NF.14s were built. They first entered service in February 1954, beginning with number 25 Squadron, and were being replaced as early as 1956 by the Gloster Javelin. Overseas, they remained in service a little longer, serving with number 60 Squadron at Tengah, Singapore until 1961. As the NF.14 was replaced, some 14 were converted to training aircraft as the NF.14 and given to number 2 Air Navigation School on RAF Thorney Island until transferring to number 1 Air Navigation School at RAF Stradis Hall, where they served until 1965. Design, Edit. Overview, Edit. The first operational version of the Meteor, designated as the Meteor F.1, apart from the minor airframe refinements, was a straightforward militarization of the earlier F9/40 prototypes. The dimensions of the standard Meteor F.1 were 41 feet 3 in, 12.57 m, long with a span of 43 feet 0 in, 13.11 m, with an empty weight of 8,140 pounds. 3,690 kilograms, and a maximum takeoff weight of 13,795 pounds, 6,257 kilograms. Despite the revolutionary turbojet propulsion used, the design of the Meteor was relatively orthodox and did not take advantage of many aerodynamic features used on other, later jet fighters, such as swept wings. The Meteor shared a broadly similar basic configuration to its German equivalent, the Messerschmitt Me 262, which was also aerodynamically conventional. It was an all-metal aircraft with a tricycle undercarriage and conventional low, straight wings with mid-mounted turbojet engines and a high-mounted tailplane clear of the jet exhaust. The Meteor F.1 exhibited some problematic flying characteristics typical of early jet aircraft. It suffered from stability problems at high transonic speeds, large trim changes, high stick forces and self-sustained yaw instability, snaking, caused by airflow separation over the thick tail surfaces. The longer fuselage of the Meteor T.7, a two-seater trainer, significantly reduced the aerodynamic instability that the early Meteors were known for. Later Meteor variants would see a large variety of changes from the initial Meteor F.1 introduced to service in 1944. Much attention was given to raising the aircraft's top speed, often by improving the airframe's aerodynamic qualities, incorporating the latest engine developments, and increasing the strength of the airframe. The Meteor F.8, which emerged in the late 1940s, was considered to have substantially improved performance over prior variants. The F.8 was reportedly the most powerful single-seat aircraft flying in 1947, capable of ascending to 40,000 feet, 12,000 m, within 5 minutes. Construction, Edit. From the outset, each Meteor was constructed from several modular sections or separately produced units, a deliberate design choice to allow for production to be dispersed and for easy disassembly for transport. Each aircraft comprised 5 main sections: nose, forward fuselage, central section, rear fuselage and tail units. The wings were also built out of lengthwise sections. The forward section contained the pressure cabin, gun compartments, and forward undercarriage. The center section incorporated much of the structural elements, including the inner wing, engine nacelles, fuel tank, ammunition drums, and main undercarriage. The rear fuselage was of a conventional semi-monocoque structure. Various aluminium alloys were the primary materials used throughout the structure of the Meteor, such as the stressed duralumin skin. Across the Meteor's production life, various different companies were subcontracted to manufacture aircraft sections and major components. Due to the wartime workload on producing fighter aircraft such as the Hawker Hurricane and Hawker Typhoon, neither Gloster nor the wider Hawker Siddeley group were able to internally meet the production demand of 80 aircraft per month. Bristol Tramways produced the forward fuselage of the aircraft. The Standard Motor Company manufactured the central fuselage and inner wing sections. The Pressed Steel Company produced the rear fuselage, and Parnell Aircraft made the tail unit. Other main subcontractors included Bolt & Paul Aircraft, Excelsior Motor Radiator Company, Bell Punch, Turner Manufacturing Company, and Charlesworth Bodies, as many of the